AutoCAD. Before importing the points, we'll just go to AutoCAD and check our file whether there are any unusual points or wrong data. So we will filter it just quickly. We go to AutoCAD. Here is my data. So you can see I have two objects only, points and text. These points and elevation written as a text. So before this, here as you can see, my elevation is around 45, 46, 44, all above 40. Sometimes what happen when we import the data from GPS or total station, whatever instrument we are using, sometimes it brings some 0 points or we create some 0 points. So we just need to check there should be no 0 point. Otherwise, when the Liscad will interpolate the levels, it will match with the 0. So here in this case particularly, you can see 44 to 0. That's not realistic. That's wrong information we are giving to program. So we will just simply check. We will go to quick select and we select point position Z equal to 0. We just enter 0. Yes, as you can see here, 0 item selected. We don't have any 0 elevation point in this file. Other thing we can check is whether, as we know that in this file, in this particular survey data, there should be no point below 35. You can assume your value as per your data. So I go to position Z and I say there's less than 35. At least I am just saying, but my points are all above 40, but I am just giving more value to filter the point elevations. So I just select OK and it said 0 items selected. If there are any, so we will delete them. So our file is okay. As we check, we just close and save it, or don't save it, because I didn't save because there was no change. So we go to Liscad. Here we imported our file. As you can see, these small points here, this is our raw survey data. We go to display. So if we right click on screen anywhere, so this window pop up. Display feature, display groups, fit, zoom in, pan, many others, but most important are these first two. Other tools we can use from the toolbars also. So we go to display feature and here we can select what we want to see and what we don't want to see. We want to see points, cars, shape lines, because we don't have anything else other than point or text in this particular file. So if this is all checked, it doesn't make difference. So I will check here text and select OK. What it does, it show me the text along the points. If I go and uncheck this, as uncheck the text, so text disappear. I will keep it check here. And we have in display feature, we have many other menus like point, if we want to hit symbol or not, group, identifier, all those things. If we want to see, we have many others which I will explain you in other tutorials later. So for now on, we only check text, so we can see our text along the point. We can see its Z value. The text is actual the Z value. After importing the points and after checking the display features, now we right click again and there is another thing, display groups. As in the previous tutorial I told you, the groups in Liscad is same as layers in AutoCAD. So we can turn off or turn them on. In AutoCAD I have these layers: 0, default, point, we know text. So we know text file, we know text layer, it has only text in it. If we uncheck it and press OK, you can see text disappear, just like layer on and off in AutoCAD. If you go again to this display groups, check this and my points are in zero layer. We check this, uncheck this, and check text. Press OK. Now text appear but points disappear. Okay, so here we can check or uncheck our layers. We can check or uncheck our display groups. Display groups are same as layers in AutoCAD, as I told you before. Next thing is, after importing the points into Liscad, the first thing we will do, we will filter the points. So what is filter and how to filter? We will go to task, utilities, maintenance, and filter points. So this window appears. It shows filter points. It's asking for index region size. I choose it maximum, it doesn't make difference. Filter X and Y, yes. We have to filter their X values, Y values, and we check Z value also. So here the tolerance we are giving is 1 mm, 0.001. What it will do, if I press OK, what this filter point feature will do, it will just delete the points within this specified tolerance. So we give here tolerance 0.001. If there are any points where we have difference less than 1 mm, so it will delete, and it was we will delete some, it means extra points. Press OK, it filter the points. Then we go and we optimize the database. We just click and it say database has been successfully optimized. Done. What optimization done? Why we do optimize? Optimize is to improve its response time. So if we have too many points, too many lines, we will just do optimize, and it work like a purge in AutoCAD, something like that. So we just optimize our data file. Then we go to task, and here you can see, as its name says, terrain modeling. So here we will do our model. We select terrain modeling. We go to modeling, validation. Validation is giving us region size, which I told you I am always selecting 5000, which is maximum as AutoCAD gives. Point with duplicate XY coordinates. Okay, so validation. What validation is doing? It will identify any error based on the information we are giving it. So any error, it will find out if there is any error. So region size we selected 5000. Point with duplicate XY code, we keep it check. Yes, this is the most important thing to do in validation. We will select if there are any duplicate points which are over and above in the file. So it will filter those, and it will tell us that this point and this point, it gives the number of point or duplicate. So we will correct it if there are any. So we check break line crossing. I don't have these things, but okay, let it go, let it check. I press OK, and validation report came. In validation report, it says no error encountered. So validation succeeded. We press OK. Then we go to modeling, and we form model. Form model, this window appears. We will give the name of the model. In my case, I am giving, because this file is original ground levels, in short I am writing it OGL. We select a region size 5000. Search distance, this is the most important thing in this window. What is search distance? Search distance is actually how model is formation. What is model formation? Terrain modeling formation is, so it will interpolate all the levels and create it a surface, which you can call some programs or other names. We can call it a tin surface or model formation. So we are going to create model formation. For that, search distance we have to give which are points maximum from one point to second point, the maximum distance. Okay, in my case here it is maybe it's around 120 or 110, the maximum distance from the point. They are not on a uniform distance because it's a raw data as survey did the survey and I downloaded it from the instrument. So roughly my points are around 100 120, but I am giving here 150. So what it will do, it will join all the points, it will interpolate all the points. Those distance between those two points are less than 150. So 150 is big enough for me here. You see as per your file. So you just roughly see where is the biggest gap and how much it is. So as per that you give figure above than this here in search distance, so it will match the points. I press OK and you can see here tin surface appear. When I zoom, it disappear. For that I will go to display feature. In display feature, as I told you, I will explain you some features later as it comes to use. Here we will go to model. So this is our model tab in display feature. Here we have options of triangles, triangle numbers, contours and many other. Now if I check this triangle option and press OK, you can see it shows all the triangle, all the tin surface, what we call it. So it interpolated all the points, as we can see, it interpolated all the points and created a tin surface successfully. So I just go here, display feature, I go to feature, I don't want to see the text, I uncheck it and here it is. This is our tin surface. Second thing we can do, we'll go to display feature, model. For example, we don't want to see the triangles, we want to see contours, which is another form of another way to show the surface terrain. So we go to contour, press OK. What it does, it is showing us all the contour. It's showing us in a contour format the surface. We go there again, display feature, model tab, contour. We check here values. So you can see there were values here. Okay, values along the contour. I go again to display feature. We can turn the values off by selecting none. So there will be no values with the contour. Second thing here, most important thing is we have intervals, intermediate contour interval and index contour interval. Now what Liscad means by intermediate interval, intermediate contour interval or index contour interval. Intermediate contour interval is a minor contour. As you guys may know that contours are two contours always. When we draw contour for any surface or for any terrain, there are two types of contour. One is minor and one is major. So by intermediate contour interval, Liscad means minor contour. By index, it means major contour. So between the, as in you can see in the drawing right down here, we have this dark line where my cursor is, magenta color dark line, and we have these thin gray color lines. These gray color lines are minor contour and the dark one magenta color is major contour. So what it is, you can see there are more lines, more gray lines and less magenta lines, because we set here interval 5 as the intermediate, 1 as the intermediate and 5 as contour interval. It means now this index contour, which is major contour, as I told you, major contour elevation difference is 5. So one major contour to other major contour, it is 5 meter change in elevation. Intermediate contour, which is minor contour, as you can see the gray ones, their elevation difference is 1 meter. So you can see it comes close to each other as per the surface. We can reduce this, I will reduce now to show you. For example, I will do this intermediate interval contour interval 25 centimeter and measure, let's say, 1 meter. Now you can see the whole look has been changed. What it means, they become congested. Yeah, they become, the contours come closer to each other. Here now, for example, you can see this magenta line. From here to this line, the difference of elevation is 1 meter. As we set it here in the display feature model tab, we set it index contour interval 1 meter, which means major contour, the elevation of change is 1 meter between this magenta line, between all the magenta lines. You can see from here to here it is 1 meter, then from here to here change of elevation is 1 meter. In between it's showing us 4 lines. So from here to this minor 25 centimeter, then from here to here 25, 25, 25. So 1 meter, 25 by 4, 1. So this is how we can set our contour intervals, and this is how we can make model. So this was our tutorial in which we learn how to import points, how to do all the how to import point, how to check before importing the points, how to check the file if there is anything extra so we can delete. So we imported files, we understand what is display feature and display group. Filter point chart, we explained how to filter point. We understand what is optimization, validation, and we made model, and we learn how to make model in Liscad, and we learn how to change contour intervals and other model settings. Thank you guys for watching. So today tutorial is done. Yeah.